Hello, and welcome to my podcast. Today, I'm going to be speaking to you about these things, speakers, or what they're more formally known as the loudspeaker. We wake up to the sound of an alarm, watch the news and listen to the news on our TV or our radio. We speak to friends and family on the phone, and we can listen to music on a hi-fi, PC or in our cars. These are some of the examples of loudspeakers that we are surrounded by in everyday life. The first electrical loudspeaker was patented in 1876 by Alexander Graham Bell as part of his telephone system. Improvements were made by various people over the years in attempts to better performance and increase sound quality. In the year 1898, Oliver Lodge established a modern design involving a moving coil. However, it wasn't until 1924, a whole 26 years after the establishment of the coil driver, that the loudspeaker was patented in its most common form, as we see it today. This was done by Chester Rice and Edward Kellogg, who had improved upon Oliver Lodge's initial moving coil design by adjusting its mechanical properties, and as a result, they managed to reduce distortion and increase audio quality. From here, they began to sell loudspeakers to the public under the name Radiola. Now that we know a bit more history, I think it's time that we learn how these things actually work. A loudspeaker works on the basis that like charges repel whilst opposite charges attract, and that when current flows through a conductor, a magnetic field is produced around it. There are two important components in a speaker that cause movement. This is the voice coil and the magnet. The voice coil is a long winding piece of copper that is wrapped around a circular drum called a former. The voice coil is then suspended above the center of a large magnet, and the ends of it are attached to terminals on the basket. As electrical signals are sent to the voice coil, current flows through the wire and a magnetic field is produced. The magnetic field due to the current flow interacts with the magnetic field of the magnet, and as a result, it either draws the speaker down towards the magnet or pushes it away. The voice coil and former are attached to the diaphragm, and so as the voice coil moves, the diaphragm moves with it. The spider and suspension ensure that the diaphragm moves directly up and down. It is this movement of the surrounding particles that we can hear.